This is Module 1 topic, the coordinate system. Make sure you have your notes in front of you. So let's take a look at the top. It talks about some definitions that we need to label on what we call a coordinate plane. And a coordinate plane is made up of two axes. We have the x-axis and the y-axis. The x-axis is the axis that goes horizontally left to right. It works like a number line with 0 being here. Numbers to the left are negative, numbers to the right are positive. The y-axis works like kind of like a thermometer, with 0 being here and degrees above 0 is above the 0, and then degrees below 0 are in the negative direction going down. So that kind of tells us something about directions. We know that the going to the right on the x-axis or up on the y-axis are positive directions. Going left on the x-axis or down on the y-axis are negative directions. Every location in the coordinate plane is designated by what is called an ordered pair, and we're going to look at locating some points in a minute. Ordered pairs are written this way with x comma y in parentheses. X is always given first. Now, when the axes intersect, there is a point where they intersect, the x and y axis, and that point is called the origin. And the origin has an ordered pair of 0, 0. So it's where the 0 on the x-axis meets the 0 on the y-axis. That intersection of those two axes also divides the coordinate plane into what we call quadrants. There are 4. This is quadrant 1, and it's always designated with the Roman numeral. Quadrant 2, quadrant 3, and quadrant 4. If you have a hard time remembering that, think of a clock, and if you look at where we have, oops, that's supposed to be 4 and 5. I numbered that wrong. 10 and 11. If you look at where 1 o'clock is, it's in the upper right-hand quadrant of the clock. That's where the first quadrant number is, right there in the upper right. If you take the 11 on a clock and turn it into a Roman numeral, that matches the 2. The 3 doesn't work, but the 4 does. 4 is in the lower left, and we just show it, lower right. We show it as a Roman numeral. So let's look at locating some points in that coordinate plane. Example 1, I have A through F points, and we're going to locate them and then say what quadrant they are in. So point A is the point 2, 2. Since the x comes first and then the y, that means to go positive right 2 and then up 2. So point A is located there, and that is in quadrant 1. Point B is negative 6, 0. So starting at the origin, we go left 6, and then the 0 says don't go up or down. So that point is right there. By the way, that was A. Point B is there. It's not in a quadrant. It's on the x-axis. So that's how you give its location. Point C is the point negative 4, so we go negative 1, 2, 3, 4, up 1, 2, 3. I knew it was up because this was a negative, this was a positive, so it was left and up. And that is in quadrant 2. Point D is the point 5, negative 7. Positive 5 is go right 5 and then down 1, 2, 3, 4, 5, 6, 7. So there is point D. It's in quadrant 4. Point E is the point 0, 4. Now be careful with this one. 0 means don't go left or right, and then 4 means go up 1, 2, 3, 4 because it was positive. So E is right here, and it is located on the y-axis. Finally, we have point F, which is the point negative 6, negative 9. So I go left 6 and down 9, which is right here. So there is point F, and it is in quadrant 3. That should be just a quick review for you locating points. The only other thing I want to show you before we move to the next topic is ordered pairs that satisfy a given equation. So to find ordered pairs that satisfy an equation, you select a number for one of the variables and you substitute it into the equation for that variable, and then you solve for the other variable. So if we use this equation, 2x plus 3y equals 6, that you're given in example 2, we're going to complete the table of values and graph the line. So you notice we have what's called an xy table. I've got a 0 here in the x spot, so I go back to my equation. I take out the x, I put in a 0, plus 3y equals 6. That just makes 0. So 3y equals 6. Divide by 3, and I get y equals 2. Next, I have a 0 in the y spot. So I again go back to my equation, 2x plus 3, take out the y, put in the 0, equals 6. That goes away, it makes a 0. I have 2x equals 6, divide by 2, and I have x equals 3. Now we're going to continue with these last two partial ordered pairs. So now I have a negative 3 in the x spot. So that's 2, take out the x, put in the negative 3, plus 3y equals 6, or negative 6 plus 3y equals 6. Add a 6 to both sides. We get 3y equals 12. Divide by 3, and we get y equals 4. Make that negative a little bit bigger so we remember that. And finally, we have a negative 4 that goes into the y spot. So 2x plus 3 times negative 4, I took out the y, put in the negative 4. 2x minus 12 equals 6. Add a 12 to both sides, and I get 2x equals 18. Divide by 2, and I get x equals 9. Now, I want to show you what this looks like when we take those ordered pairs and we plot them on our coordinate plane. We have the point 0, 2, that's right here, 3, 0, right here, negative 3, positive 4, there's that point, and finally the point positive 9, negative 1, 2, 3, 4. I'm going to use a ruler since I can't draw a straight line. And if we line those up, you can see that these solutions, all the solutions to the equation that we were given, when plotted, they form a straight line. And that will always be true, which is why an equation like this is called a linear equation, because it graphs to form a straight line. So the conclusion here is the graph of any first degree equation in two variables is a straight line. So if one of those points had been off somewhere in another spot, not lining up, we know that we made a mistake.